If you don't have one, grab one. Alright, simplifying radicals. What you need to do is find your factors and perfect squares. Do you guys know your perfect squares? Yeah? Think of it this way. What's 1 squared? 1. What's 2 squared? 4. What's 3 squared? 9. Okay, so 3 times 3 is 9. Okay, 4 squared is 4 times 4, which is 16. 5 squared? 25. 6 squared? 36. Let's stop there, so I don't think anyone's reading that. Maybe there. Alright, so if I look at the square root of 12, you'll notice 12 is not up here, so 12 is not a perfect square. Can I break 12 into one of these numbers? 4 and 3. So this is 4 times 3. Everybody agree that 12 is 4 times 3? Okay, so when I take the square root of 4, what is that? 2. So when I take the square root of 4, I pull 2 out, and I'm left with the square root of 3. Okay, you guys should have done this about the end of last year. I don't know if everybody got to it.
I failed this section.
Okay. Alright, 200 is broken down. What goes into 200? That's perfect square.
25.
What else? 100. So 200 is 100 times what?
2.
2. What's the square root of 100?
10.
So when I pull out the square root of 100, I replace it with 10, and then I still have the square root of 2. Okay? But since I have that 2 out front to begin with, I'm taking 2 times 10. What's 2 times 10? So this is 20 square roots of 2. Okay. If you have multiplied radicals, all you're going to do is take the stuff on the inside. What's 8 times 8? So this is the square root of 64. What is the square root of 64? 8. So this one is a nice, wonderful, perfect number. Okay. What's the square root of 144? 12. So this one's just done. This one we gotta break down. What is a perfect square that goes into 175?
25.
25. So 25 times what gives me 175? 7. Are you sure?
Yeah.
Okay. Alright, what is the square root of 25? So when I pull out the square root of 25, I have 5 square roots of 7. Okay. Here, what's the square root of 36? 6. So I have that 2 out front already, so 2 times 6 gives me 12. Okay. How are we doing? Okay? Okay, I think we'll do this one row and then we'll call it good. Square root of 900. What goes into 900 that's a perfect square? 3 and... I think 3 is too small.
Well, the square root of 900 is 30.
So it's a perfect square? Okay. So 3 times 30
90.
gives us 90. Here I got 10 times 2. What's 10 times 2? So I have the square root of 20. Can I break square root of 20 down into perfect squares? Yeah, what? 4 and 5. What am I going to pull out?
2.
A 2. Good. Because square root of 4 is 2. So 2 square roots of 5. Here you'll notice that there's like a 1 hanging out in front. So you gotta take the outside stuff and multiply it. So 1 times -5 gives me -5. And then take your radical stuff and multiply it. 5 times 5 is... And what is square root of 25? 5. So this is like -5 times 5. So total final answer. Nice. Alright. We're gonna stop with simplifying radicals there. I feel like we're getting decent at it. Alright. Flip your page. We got Pythagorean theorem. You should have also, I think, used this before. When it comes to your answers, this leave it in simplest radical form thing is what we were just doing. And real world problems, like what we do at the bottom here, in the real world, you're not going to walk around like, oh, that's 2 squares 2 feet long. Real world stuff, throw it in your calculator and get the decimal, okay? When it says simplest radical form, that's the stuff we were just doing. Does that make sense? Yeah, okay. All right. Pythagorean theorem we use to find a missing side of a right triangle. What's it mean to be a right triangle? Yeah, 90-degree angle somewhere on that triangle. So super, super important thing. Pythagorean theorem does not find you angles. It finds you sides. Okay? A and B, we call the legs. They are different than the legs of an isosceles. How I like to think of it as they are the things that touch the right angle. So those legs make up the right angle, they touch the right angle. The C is the thing, the only side that doesn't touch your right angle. It's across from it. We call it the hypotenuse. Cool thing, maybe I'll throw this in there. Your hypotenuse, always your biggest number. So your C, always your biggest number. Alright, and then how Pythagorean theorem works. A squared plus B squared equals C squared. Y'all have heard that before, right? Okay. Alright, so here, do I have A, B, or C? Like, what are 12 and 9? A and B, because they touch my right angle. It doesn't matter which one you use as A, which one you use as B, as long as they're A and B and not C. Okay, so here I got 12 squared plus 9 squared equals x squared. If I were you, I like to save steps. I would just punch this all in a calculator. If you do 12 squared plus 9 squared, it should just spit out a number. And what number does it give you? What? 225? So 225 equals x squared. And then how do I get x by itself? Square root it. Yeah, the opposite of squared is square root. What is the square root of 225? 15. A nice, wonderful, solid 15. To check to see if your answer is right, is C 15 your biggest number on there?
Yeah.
Yeah. So, I mean, it's not like 100% guarantee that it's right, but at least a little bit of a check. Alright, next one. What, do I have my C or am I looking for it? You have it. What is it? 10. Okay? So then your other two stuff are your legs. Like I said, doesn't matter which order you go in. So like x squared plus 4 squared equals 10 squared. Here you can't just punch it in because you're going to have to subtract. So what is 10 squared? 100. What's 4 squared? How do I get x squared by itself? Subtract 16, I'm left with 84. Is 84 a perfect square? No. So when I take the square root of it, what number goes into 84 that is a perfect square? What'd you say? Four goes in there. 4 and what? 4 and 21. So pull out that square root of 4 and I get 2 square roots of 21. Good. Somebody set up my Pythagorean theorem for the next one. Six squared, 36. 9 squared, 81. Then what? Subtract. We get 45. Okay, now what? Square root it. What can I break 45 into? 9 and. So if I take square root of 9, I get. So 3 square roots of 5. Alright. Questions there? Okay. Like I said, the real world stuff, we're just going to straight up throw into our calculators when it comes to finding side lengths. Alright. We got a roofer that has a 16-foot ladder, leans it against a house. If the base of the ladder is 5 feet from the house, how high up the house does the ladder reach? Triangle. If my ladder is getting leaned up against the house, that 16 is going to be my hypotenuse. Okay, here's my ladder with all the steps, and here's my house. Beautiful, right? So cute. It says the base. Anytime you see the word base, the base of the ladder, that's going to be this bottom part. And then I want to know how far up the house it goes, so that's our x. Okay, everybody good with the picture? Alright, set up my Pythagorean theorem for me. Perfect. 5 squared, 25, 16 squared, 2, 5, 6. Subtract your 25. We get 231. And last thing to get x, we gotta square root. So punch in, since this is a real world thing, punch in the square root of 231 and give me one decimal spot. 15.2. And then real world, we need labels, so 15.2 feet. Computer monitor. You guys know this about computers and TVs, that they measure by the diagonal? Because that's the biggest number? Like, how cheap is that? Isn't that lame? I think that's kind of lame. Alright, our diagonal is a 19-inch. The height is 11. I want to know what the width is. Set up my Pythagorean theorem.
X squared plus 11 squared equals 19 squared.
Beautiful. 11 squared, 121. 19 squared, 361. Subtract your 121. We get 240. Square root it. Give me one decimal spot. 15.5, and what's my label in this one? Nice. Alright. Questions on the real world stuff? Okay. This next question says triangle has side lengths 12.5, 30, and 32.5. Is it a right triangle? If it's a right triangle, the Pythagorean theorem will work. Okay? So we're going to try and set up the Pythagorean theorem And if it works, then it has to be a right triangle. Most important thing, what's my biggest number?
32.5.
So that one has to go out by itself as C. Okay? So we got 12.5 squared plus 30 squared. And we're going to see if it equals 32.5 squared. So punch this in, 12.5 squared plus 30 squared in your calculator. I got 32.5 squared. What do you get? $1,056. What? No. When you punch it all in, 0.25. So these two things are equal. So is it a right triangle? Yes. Alright. Questions on second theorem? Okay. Flip the page. Alright. Last thing is called the converse of the Pythagorean theorem. And all it is kind of what that last problem was. You are going to see what kind of triangle it is based on the Pythagorean theorem. Okay, so if a squared plus b squared equals c squared, if they're equal, we know it's a right triangle. If a squared plus b squared is bigger than c squared, it's an acute triangle. And if a squared plus b squared is less than c squared, it's obtuse. Alright, here's how I like to think about it. Starting down here, if 1 is bigger than 2, it's obtuse. Kind of like if one person is bigger than 2 people combined, they're obtuse. Okay, that's kind of how I like to think about it. One thing we do have to check though when we do this is to see if you can even have a triangle. That is always an option with these. In order to have a triangle, your sum of your two smaller sides has to be bigger than the third. Okay? So like if you take your two small sides and they are less than your big one, then you don't even have a triangle that closes. You'll have something like that. And that's obviously not a triangle. Okay? So just make sure you always check that before you do your problems. Okay? So here, what are my two small numbers? What is 3 plus 7? Is 10 bigger than 9? Yeah, so it's for sure not that, because it is a triangle. Since 2 are bigger than 1, it is a triangle. Okay, now we're going to do our Pythagorean theorem. Same deal, your small ones go together, except for this time they get squared. Okay, like our Pythagorean theorem. So 3 squared plus 7 squared, and then we got 9 squared out by itself. I don't know if it's equal or anything, so I just kind of like leave a space. Punch in your calculator, 3 squared plus 7 squared, 58. And your 9 squared is 81. So which one's bigger? 81. So 1 is bigger than the 2. So what kind of triangle is it? Obtuse. Number 2, first thing I gotta check is if it's a triangle, what's my two small sides? 4 and 11, if I add them I get 15. Is 15 bigger than 16? No, so this is not even a triangle. That's not very common, but I just want to throw it in there to make sure you know. Moving along. Number 3. 8 and 9 added together make 17. Is 17 bigger than 11? Yep. So we know for sure it's not that. Now we just gotta square them. 8 squared plus 9 squared. I know 11 squared is 121. What's 8 squared plus 9 squared?
145.
145. So here, 2 are bigger than 1. So what kind of triangle? Acute. What are my 2 small numbers in number 4? 5 and 12. 5 plus 12, 17. Is that bigger than 13?
Yes.
Now square them. 5 squared plus 12 squared, 169. And then 13 squared is 169. They are equal, which means it's a right. Sweet. What's the first thing I check? Uh-huh. So 2 smalls. 8 and 15 make 13. Is 13 bigger than 12? Uh-huh. So we're good there. Now just square them. 8 squared and 5 squared. 89. And 144?
Yep.
So 1 is bigger than 2. What kind of triangle? Obtuse. Are we good or do you want to do 6? Good?